So I've been requested to do the proof of the derivative of the square root of x, so I thought I would do a quick video on the proof of the derivative of square root of x. So we know from the definition of a derivative that the derivative of the function square root of x, that is equal to, let me switch colors just for variety, that's equal to the limit as delta x approaches 0, and some people say h approaches 0 or d approaches 0. I just use delta x, so the change in x approaches 0. And then we say f of x plus delta x, so in this case this is f of x, so it's the square root of x plus delta x minus f of x, in this case it's square root of x, all of that over the change in x, over delta x. So what I'm going to do, right now when I look at that, there's not much simplification I can do to make this come out with something meaningful. I'm going to multiply this fraction times, I'm going to multiply the numerator and the denominator by the conjugate of the numerator. So what do I mean by that? Let me rewrite it. Limit is delta x approaches 0. I'm just rewriting what I have here. So I said the square root of x plus delta x minus square root of x, all of that over delta x. And I'm going to multiply that, after switching colors, times square root of x plus delta x plus the square root of x over the square root of x plus delta x plus the square root of x, right? This is just 1, so I could, of course, multiply that times, if we assume that x and delta x aren't both 0, this is a defined number, and this will be 1. And we can do that. This is 1 over 1. We're just multiplying it times this equation, and we get limit as delta x approaches 0. Well, this is, if you view this as a minus b times a plus b, right? Let me do a little aside here. Let me say a plus b times a minus b is equal to a squared minus b squared, right? So this is a plus b times a minus b. So it's going to be equal to a squared. So what's this quantity squared or this quantity squared? Either one. These are my a's. Well, it's just going to be x plus delta x, right? So you get x plus delta x. And then what's b squared? So minus square root of x is b in this analogy. So square root of x squared is just x. And all of that over delta x times square root of x plus delta x plus the square root of x. Let's see what simplification we can do. Well, we have an x and then a minus x, so those cancel out. X minus x. And then we're left in the numerator and the denominator. All we have is a delta x here and a delta x here, so let's divide the numerator and the denominator by delta x. So this goes to 1. This goes to 1. And so this equals the limit. I'll write smaller because I'm running out of space. Limit as delta x approaches 0 of 1 over. And of course, we can only do this assuming that delta, well, we're dividing by delta x to begin with, so we know it's not 0, it's just approaching 0. So we get square root of x plus delta x plus the square root of x. And now we can just directly take the limit as it approaches 0. We can just set delta x is equal to 0. That's what it's approaching. So that equals 1 over the square root of x, right? Delta x is 0, so we can ignore that. We can take the limit all the way to 0. And then this is, of course, just a square root of x here, plus the square root of x. And that equals 1 over 2 square root of x. And that equals 1/2 x to the negative 1/2. So we just proved that x to the 1/2 power, the derivative of it, is 1/2 x to the negative 1/2. And so it is consistent with the general property that the derivative of, a to or the derivative of x to the n is equal to nx to the n minus 1, even in this case where n was 1/2. Well, hopefully that's satisfying. I didn't prove it for all fractions, but this is a start. This is a common one you see, square root of x, and it's hopefully not too complicated of a proof. I will see you in future videos.